This does not really represent a loss of learning topic, but it does represent a topic that a few folks are kind of getting stuck on as you're working on this next set of objectives. And it is all about logs, and these are the basics of them. First, a definition of a log, just to be real specific, is that a log is an exponent. You will notice in this section that we spend a lot of time talking about exponents, fractional exponents, negative exponents, a whole lot, well, not necessarily fractional exponents. You will see fractions, but the exponents will probably be negative if they're involving fractions. So I've written basic exponential form. You have the base number that is raised to an exponent and it equals an answer. A log is just another way to rewrite this, but remember that the log is always going to be equal to the exponent. So in this case, what we would do is we would take this exponent and we'd say that the log is going to be equal to it. I'm going to make that a little bit smaller because exponents are kind of tiny, but they won't appear tiny when you write the answer. They'll appear like regular numbers. So the log will be equal to the exponent. And then we have this base number that will always be the small number written right beside the log. The number that's being raised to the exponent will always be that small number written in subscript form right beside the log. And of course, your answer is the number that appears right beside the large, the log in large fashion. Now, I talk about this because logs are one of many things in math that appear kind of strange. Like you're looking at it and you're like, am I supposed to multiply, subtract, add? No, you're just supposed to juxtaposition the numbers. You're just moving them around at this particular point. In the future, you're going to solve them. But right now, you got to know how to move them, where they need to go. So this base is the small number beside the log. This answer is written beside that, and everything's equal to the exponent. Now, using letters to say the same thing, and I'm trying to keep it all color-coded. The base is A, the exponent is C, and the answer is B. If we were trying to use these letters, then we would take this A, and we would move it right beside the log, and it'd be a little bit smaller, so I'll make it a little smaller. Just a little, not that much. And then this answer B is going to get moved right over here beside that, and everything's going to end up being equal to, you guessed it, the exponent, which happens to be this C here. And the C is not necessarily small. I mean, it's about the same size as the other numbers, but that's how it appears. So you're either asked to write the answer in what is called exponential form, which is this form right here, and you can write that simply, exponential with an exponent, or it could be written in logarithmic form. We'll just call it log form. Now, here are a few examples of what you see in ALEKS when you get ready to do this problem that leads people down a wrong path. We want to write this exponential expression as a logarithmic equation. What I encourage you to do is to get out note cards and to actually write these formulas on the note card as you're working out this problem. So write logarithmic form on a note card and write logarithmic form exponentially. So let me write it as a logarithmic equation for you. So remember, this was the form A raised to the C power is equal to B. So in this case, A would be 2, C would be 0, B would be 1. And in logarithmic form, it is log base A, B is equal to C. So what would we write as our final answer? It would be log that large 2 that's being raised to the exponent. The 1 is equal to 0. That's all you write. Now, when you're going backwards and you're writing it exponentially, when you're going this way, remember that this little number is the number that you start with, the 5, and it gets raised to this exponent right here, to the negative 2, and it equals 1 over 25. I don't know, but something happens in folks' minds when they see a fraction and everything gets discombobulated. So take your time and practice this as many times as you can. As you're working on these, I encourage you to hit the review button using those 3 bars in the upper left-hand corner so that you can actually keep practicing this. before you master it, because once you master it, you can't like get a worksheet or anything about it. But if you work on the worksheets and review while you're trying to get it, that'll give you some good practice. All right, let's do that again. Oh, well, I did that same one. Now, with this one here, we're moving right on into the evaluation phase. Notice we don't know what the exponent is, or do we? So this is where our exponent rules come into play. 2 raised to what power is equal to 1? Well, 2 raised to the 0 power is equal to 1. How do we know that? Because we just wrote it right here. 2 to the 0 power is equal to 1. For this one, what can we raise 5 to get 1 over 25? Now remember your work with negative exponents. If you don't remember it, well, let me take you on a walk down memory lane. 5 to the negative 1 power is equal to 1 over 5. 5 to the negative 2 power is equal to 1 over 5 squared, or 1 over 25. So that means the answer to this question is negative 2. So when you have this expression to evaluate, what does it do? It gives you the exponent that you raise that little base number 2. Now, why is this important as we look at percents and loans? Because we need to know how to calculate exponents, because compound interest is often raised to large exponents or small exponents to try to figure out how much we needed a few years ago so that we could have a certain amount by the time our child graduated from high school or something. So the answer to this particular question here is negative 2. So we've got negative 2 and 0 for our answers. Alrighty then. Just to make up a few on the sly as I'm sitting here, remember that any number raised to the 0 power is equal to 1. You will often see this example as you're working these problems out. So when they want you to write it in logarithmic form, it becomes log base 3 of 1 is equal to 0. And if you start out with a logarithmic expression like the log base 7 of 7 is equal to 1, and they want you to go exponential with your answer, then you would write this number right here. Even though these two are the same, you're writing that 7 raised to the 1 power is equal to 7. And that's all there is. We're just writing them down right now. You're not getting into the hard, complex calculations of logs unless you go off into, say, a pre-cal or a calculus class. You will get into them there. Now, what I have right here is just a little bit of an activity that we can do, or that I'm going to run through with you right now. So what I have here is, if we were in a classroom together, or if we were near a smart board, we would put these up on the board and we move them around and try to match them up. So on this side, we've got this fish, and it's going to match up with this fish. I don't know that they go together, but anyhow, I'm going to start with this first one. Try to move it over some. All right, it says 2 raised to the negative 1 power equals 1/2. And I've got to come over here and try to find another one, but clearly it's going to be easy to find. So let me see if I can move him. Doesn't look like I can. All right, so I'm going to put this guy here, and I'm going to match this guy up with him. And when they match up, they'll go right into the spots where they're supposed to go. Good for me. I'm the teacher. I should know how to match them up. All right, so now I've got the log base 6 of 36 is equal to 2. I'm looking for 6 raised to the 2 power equals 36. Additionally, these are easy because these numbers are all different, so I need to look for the same numbers. One thing about working out these problems is if you start out with 6 raised to the 2 power equals 36, then the 6, the 2, and the 36 are also going to be in your answer. You don't have to do any kind of mathematical manipulation to them. All right, so log base 7 of 1 is equal to 0. Now I'm looking for 7 raised to the 0 equals 1. And by golly, I found it. And then we have 9 squared is equal to 81. Logarithmically, that is log base 9 of 81 is equal to 2. Last one, 4 to the negative 3 is equal to 1 over 64. And I'm looking for log base 4 of 1 over 64 is equal to negative 3. Replay this if you wish. I'm hoping that it is helpful to you. If it isn't, please send me an email. I'm happy to send you a personalized video. Good luck.